Yeah, good morning everyone. Myself, Mr. Sankur Naresh. I'm from Department of Civil Engineering, Annag Engineering College, Kodad. Today I would like to explain about one of the interesting topic, earthwork excavation and its estimation. Actually, the earthwork excavation and estimation is there in the roadworks and as well as the buildings also. But coming to my in our regulations, we had an earthwork excavation in the roadworks only. We are going to be discuss. So if you see here, I want to explain about where the roadwork excavation is going on. If you see here, there is a different types of payments here. First one is a flexible payment, and second one is a concrete payment, and it's also called a rigid payment. If you see in the case of the flexible payment, the surface course is constructed with that there is a bituminous concrete, and in the case of the rigid payment, the surface course is constructed with the in the case of the only plain concrete or maybe reinforced concrete. But the both common is subgrade. So the subgrade is going to be constructed with that soil only. This soil having the minimum bearing capacity 10% as per IRC codal provisions. If you see that there is a cross sections are here, so surface course is considered with a bituminous concrete, and base course is considered with maybe fine aggregate, and sub base course is considered the coarse aggregate, and subgrade finally we had in a soil. So that particular element is very important. You want to lay the or you want to construct the payments, so we need to have some little discussion here. So if you see that that next one, why we are going for that earthwork calculation and why it is important for us. And if you want to estimate the total cost of the payment, this cost of the subgrade is also one of the part in that. So it is needed to get the total cost actually, and if you want to budgeting also it is needed. And even though if it is also for buildings also, the earthwork quantities are needed for us. So definitely this very important topic, and also if you know this, then we'll go for a project planning and schedule and resource allocation. So in the case of the resource allocation, that means first what is needed, what type of tools are needed. Likewise, one by one, step by step, we are going to be arranging all the resources to construct the payments as well as the building foundations. And also this is also going to be used for in the case of design of the payments and design of the foundations also in the engineering application. And if you know that this one, it is very simple for us to know the quantities control. And in this phenomena I want to give some example, because there is a different types of soil as per IRC and as per Astro. So there is a black cotton soil is existed, means at the time that black cotton soil is not exhibiting the minimum 10% of bearing capacity. And in the considerations, we are also going to be look at that there are alternative soil to replace the black cotton soil. So this is very important to calculate the earthwork. And then if you see here, there is a next slide. So there is in a technical terms. Technical terms means actually generally that people they're called in site is different. And here in the case of the our theoretical examinations we call in different. So if you see that first one is in a cutting and next one is in a fill. So whenever you can go for, whenever you go cutting and whenever you go for filling, so if there is an excessive soil, so actually before going to be discuss about the cut and fill, we discuss about the actually surveying. So in the surveying, if you done that levelings, after done that levelings, and if you draw in a profile, then so that you got an existing ground profile. So in the existing ground profile, what is happen, that maybe we are also drawn that what is in a proposal level. And in that case we are going to be know that what is an amount of cut, what is an amount of fill. Anyhow, I want to define what is a cut and what is a fill here. So cutting means that excessive soil we are going to be removed from the existing ground surface. We can call it as a cut, and that somewhere we have a deficiency is there. So in that deficiency we are going to be take the soils from somewhere else, that is comes under a fill. Actually, you want to make them level. And coming to that, if you second one, that actually the quantities are calculated in terms of meter cube. And next one is a topo soil stripping. In the what is the topo soil stripping is not here. So if you remove that, there is a top soil over the existing one, we can call it is a top soil stripping. And the borrow bit, just now I discussed that in the case of the fill we are going to be borrow the soil somewhere else. So that means that wherever the soil you dig it, and then you can place here to as a part of the filling, then we can call that is a borrow pit. That means that where we are going to be exactly take the soil for sake of filling. So that is called borrow pit. It is also the construction place and the borrow pit, we can call as in a whole distance. And next one, there is a shrinking, and next one is there is a swelling. So shrinking is nothing but actually after laying the new soil, so because of the looseness, then here what is happen, we are giving the compaction over there to get the sufficient amount of the bearing capacity and compaction factor, so that the soil is going to be shrinking here. So that is also called shrinking. And swelling is nothing but because of the looseness that is absorbing the water, then he is going to be swell. So it is very very important, we are going to be focusing on the swell and shrinkage while you are going for a construction. And next one is a subgrade. Already we discussing that there is a cross section of the pavement. In the cross section of pavement, that first one is start with that subgrade. I want to tell one more thing here. So the subgrade thickness is not going to be given by anyone. That means the designs where actually that pavements are is constructed in maybe by using the IRC codal provision. If it is IRC 58 2002 for the receipt payments, IRC 37 2022 is for the flexible payment. So anyhow, so that subgrade design is not going to be given. The thickness of the surface course will come, and thickness of the subbase course and base course will come, but the thickness of the subgrade course is not going to become. That is a called subgrade. That is a part of the cross section of the flexible payment and rigid payment. And coming to that embankment, embankment is nothing but actually what is happen in sometimes that profiles, the profiles here very much more than the existing ground profile, very much more than the proposed level. In that phenomena, what is happen, we are going to be take that, there is that excessive portion we need to cut it and we need to place it as an embankment. And coming to that slope, here what is happen, there is we want to go for a drain off the rainwater from the road surface, we are providing the drain off. And coming to that benchmark, here the benchmark, what is happen, that's if you want to define the benchmark exactly, so that is in a reference standard point which is fixed by the Survey of India. Actually it is helpful to determine the levels of the ground surface. So that these are all the technical words in the earthwork excavation and its estimation. And coming to that, next one is factors affecting the earthwork quantities. So if we see here the three factors we are seeing here, that first one is terrain characteristics, and second one is soil conditions, and next one is construction design. So in the terrain characteristics means if it is having the slopey nature or hilly nature, definitely that quantity is going to be varied from compared to the normal soil conditions. And then coming to that next one is in a soil conditions. Actually, just before we discussed that there is CBR value. The CBR value is very less, means definitely in that particular case what is happen, we are going to be remove the soil, and then we are going to be replace the soil with that and another type of material. And coming to that, I will give them one example. The black cotton soil is having the less strength when compared to the gravel. So if you want to use the black cotton soil alone, the thickness of the black cotton soil is very more, because you want to get the little CBR also. So in that particular consideration, you want to keep the black cotton soil as a subgrade material. At that case, definitely the quantities is going to be changed. And coming to that, this next one is in a construction design. The construction design is also maybe based on the quantity, so that maybe the thickness is very high, okay, and at the time also the quantities is going to be varied. And coming to the next one, it need a site surveying actually. So if you want to really do the earthwork calculations, that practically, that first you want to go with that, there is surveying here. So in the surveying, what is happened, just before we discuss the one point, that is called the benchmark. So by using this benchmark and by using the surveying levelings, that actually two types of levelings are there. One is a rise and fall method, and one is a height of the instrument method. So if you use any one of the method in that, then we can calculate the RLs of the ground level for each and every 5 meters of interval, and then we are going to be know that RLs. After getting the RLs, we are going to be draw the existing ground profile, and then we are make it that what is in a proposal level, so that we are getting the what is an amount of the quantity is needed, what is an amount of the cutting is needed. Likewise, by see that diagram itself, we are going to be understand. So definitely the surveying investigation is needed in that soil, and also that there is a soil investigation also needed. That what is a soil investigation we done here? There is a type of soil and the bearing capacity. Likewise, we are going to be investigating all the parameters. And then in next one, if you see here, there is methods of the earthwork volume calculation. There is a first method, mid sectional area method. And in this mid sectional area method, that quantity, actually this is an output we are getting from every method. So quantity is equal to capital B into D plus SD square all into capital L. So capital L is nothing but the length of the road. That means, for example, if you want to construct or if you want to calculate in a subgrade soil for the Anantagiri to Kodad, then the distance between the Anantagiri and Kodad is comes under an L. And then coming to the B is nothing but it's in a width of the road. So if it is in a 2 lane and 3 lane or 4 lane, maybe one lane is 3.5 meter as per IRC codal provisions. And then small d is nothing but, so just now we discussing that RLs we are getting. So that RL value we are taking as the depth here. So that mean depth we are going to be taken. The mean depth, how we are calculating the mean depth? So that is equal to d1 plus d2 by 2. Then we are getting the mean depth. So that by using this method, we are also going to be calculate the there is a quantities here. If you see that second one, mean sectional area method. In this mean sectional area method, so Q is equal to, that means quantity is equal to mean area into L. So previously we are only done the mean depth calculation, but first here we are calculating the areas, that is A1 is equal to BD1 plus SD1 square, A2 is equal to BD2 plus SD2 square. So if you calculate the mean area, means A1 plus A2 by 2, that mean area multiply with the length. Length also we know that just the distance between the that Anantagiri to Kodada, that is the distance we are going to be taken. And if you see here, there is an S value, I want to describe it. S is nothing but it's in a slope. For example, horizontal, actually S value is given in the problem, maybe 2:1 they may mentioned. So in the such cases, we are taking the S value is equal to 2 actually. And coming to that next one is an a prismoidal formula method. So in the prismoidal formula method, quantity is equal to L by 6 whole into A1 plus A2 plus 4 into AM. So that AM is nothing but A mean. That is A mean. Now we are going to be calculate the A1 plus A2 by 2. Likewise, we are going to be substitute the all values in this formula. Then you are getting the quantities of earthwork by using the prismoidal method. If you see that, I want to summarize it because it's very important. The methods we have, so the mid sectional area method and mean sectional area method and prismoidal formula method. And the next one is, if you see that, there is an empirical example. Okay, the numerical examples we want to discuss for these three methods. So if you see that, there is a first problem: calculate the quantity of the earthwork for 200 meters length. That means a capital value, capital L value, we are going to be take it as in a 200 meters for a portion of a road in a uniform grounds, and the height of the banks at the two ends being 1 meter and 1.6 meter. That means here they may given the d1 is equal to 1 meter and d2 is equal to 1.6 meter, and the formation width is 10 meters. That means capital B is equal to 10 meters, and ideal slope, the 2 is to 1. Then S is equal to, we are going to be take it as in a 2. So in this there's also going to be mentioned that they assume that there is no transfer slope. So in this problem, if you see that mid sectional area method, that what is the formula we have? Capital Q is equal to, that is quantity is equal to BD plus SD square whole into L, that mean depth. So first we need to calculate the mean depth, that is equal to d1 plus d2 by 2. That here d1 is equal to 1 and d2 is equal to 1.6. So in the case of d1 is equal to 1.6, d1 is equal to 1.6 and divided by 2, then you got the mean depth is equal to 1.3. Then if you substitute Q is equal to there is 10 into 1.3 plus 2 into 1.3 whole square you whole into 200, then you got 3276 cubic meters. So likewise, we need to go for a calculation of the earthwork quantity by using the mid sectional area method. And the next one, there is next one, there is one more problem we are going for mean sectional area method. So in this mean sectional area method, if you see that problem, calculate the quantity of the earthwork and the length of the portion of the road in uniform grounds of height banks at two ends being 1 meter and 1.6 meter. That means if you see that the problem is almost equal, then almost equal, it's an almost equal problem, they're not changing any parameter, but we want to change the method here. So in that particular consideration, Q is equal to mean area into length, and A1 is equal to there is that A1 is equal to B into D1 plus S into D1 square. So likewise, we are calculating A2 also, B into D2 plus S into D2 square. Then you can calculate the A1 and 2. After that, we are calculating the mean area. So that mean area is equal to A1 plus A2 by 2, that we are getting the 16.38 square meters, because area units are square meters only. That quantity units are always meter cube. So Q is equal to mean area into length, then that is 16.38, we are getting multiply with the 200, we are getting the 3312 cubic meters. Likewise, we are calculating the quantity of the earthwork by using this mean sectional area method. And coming to that next one, there is a prismoidal method. This is also if you see here, this is also same, but that way of calculation is different and the formula is different. That Q is equal to L by 6 into A1 plus A2 by A2 plus 4 AM. So that means here we need to substitute all the values. L is nothing but 200 by 6. That A1 we are getting 12 and A2 we are getting 21.12 and plus 4 into AM we are getting 16.38. Finally you got 3288 cubic meters. Likewise, we are going to be do the problem. And this is about the prismoidal method. And I want to tell about, out of three methods, this prismoidal method is giving the that accurate quantities. Maybe in the gate oriented they may asking the questions, then you can keep the prismoidal method is the best method out of that remaining two. Okay. And then if you see here the cutting and filling, already we discussed in the cutting and filling. So in the cutting and fill, first, then first we need to draw that there is an existing ground profile, and then we need to draw in a there is a proposal level, so that we are going to be get what is an amount of cut, what is an amount of fill. For example, the cutting quantity we are getting, when we are going to be know that whether it is in a cutting or filling, if it is in a theoretically, the quantities, that quantities, the proposed levels are more than the existing level, it comes under a fill. But that existing levels are more than the proposed level, it comes under cutting. So here there is a balancing one thing is there. So we are calculating cut, and simultaneously we are calculating the fill. If it is both quantities are equal, means no need to go for a borrow bit. So if it is not equal, means we need to go for either borrow fit, or we need to go for an embankment. So the filling value is more, then we need to go for a borrow pit and take the soil from that. And if it is only cut is there, then at the time the excessive soil we are going to be keep it as an there is an embankment. Or if it is balancing, means no need. But if it is fill, means definitely we are also going to be go for a cost estimation for it. Likewise we are going for a problem. And then if you see here one more numerical demonstration, so regarding the swell factor and at the same time the shrinkage factor, if you see that the swell factor is equal to volume of loose soil by volume of in situ soil. So in that volume of in situ soil, here that shrinkage factor is equal to volume of compacted soil by volume of the loose soil. So if you see here, the data is given, site area is given 10,000 square meters, and cut depth is given 1.2, fill depth is given 0.8, and swell factor is also given 1.15, and shrinkage factor is also given and 0.95. So likewise here we have the data is given, so that we are calculating the quantities. So cut volume is equal to, how can calculate the cut volume? That is equal to area multiply with the depth. So the depth of the cut volume, so that 10,000 into 1.2, 12,000 cubic meters, and fill volume is equal to 10,000 square area into 0.8, that's an 8,000 cubic meter. So adjusting the cut, then with the swell factor, that is equal to 12,000 into 1.15, that is equal to 13,800 cubic meters. Adjusting the filling volume with the shrinkage factor, that is 8,000 into 0.95, that is equal to 7,600 cubic meters. That excessive cut is equal to that is what is in a quantity we are getting the swell volume of cut, and what is in a excessive quantity we are getting at the volume of the fill. So that is equal to 13,800 minus 7,600 cubic meters, that is equal to that excessive cut is equal to 6,000 cubic meters. Likewise we are going to be balancing the earthwork just before what we discussed. If you see here, there is some of the MCQ questions are there. So that if you see that first MCQ, which one the following the best describes the term the cut in the earthwork excavation? So that option 1, the adding of the soil to raise the ground level, remove the soil to lower the ground level, compact the soil to increase the density, and strip in the top surface of the soil. And if you see that removing of the soil to make them ground level lower, so that is a B option is a right for that. And simultaneously if you see that they may asking that there is what is swell factor, and similarly what is shrinkage factor. If you want to utilize the swell factor, volume of loose oil by volume of the induced oil, this formula, then automatically you are getting the there is that 1 cubic meter is given, and swell 1.3 cubic meter is given, so that you got a factor. So how you are getting this factor? So if you see that formula, swell factor, volume of the loose soil by volume of in situ soil. So what is in a volume of loose soil in the case of the second problem? 1.3. What is in a volume of in situ soil? So there is in a 1. So that what is the value here? 1.3 is an answer for that. And then automatically here also third one, if you see that there is an other materials to rise the ground level to desired elevation to known as an, it's a fill actually. It's not a cut, it's not a grading, it's not an excavation, it's called a fill. So that here we are going to be give option fill. And simultaneously if you see that there is an shrinkage factor also, if you use the formula you are getting easily. So that if you see that the term describes the rise of the structure made of soil, often used to road of railways. Then we can, what you can call it is an embankment. So just now we discussing that it's an embankment. And coming to that, if you need to achieve 10,000 cubic meters of compacted fill with a shrinkage factor of 0. How much loose soil is needed? So likewise just multiply with that 0.9 with 1,000, then you got a value. So then that is equal to maybe 900 meter cube. So that answer is the value, actually it is an answer is value is C, 1,000 cubic meters only. Likewise you have one more question is also there. The following is used to determine the elevation of the land surface and assist in a planning of the earthwork activity. The answer is the contour line. That means just in this PPT I told that first if you want to know that what is an existing ground profile, you want to go for a surveying, but unfortunately it is not needed if the contour maps are available. So that likewise we are also going to give the importance for the contour map. If you see here, there is in a textbooks that estimation costing in civil engineering, the theory practiced by B. N. Datta. So most of the people are the faculty, they are following this textbook only. And coming to that, there is in a GS Baradi is also there, and that one more textbook by B. N. Datta, estimating costing in for civil engineering examination by and B. N. Datta. So likewise these are the textbooks are available on the estimating costing. And thank you so much. Any doubts regarding, just you can comment on my video. Thank you.